Greeting. Today we are going to present about our beam.
My name is Patipol Puchum.
My name is ถาปกรเกิดเกาะ
My name is Pokin Chilawiryaport.
My name is Charita Navalaphor.
My name is ภาคินน้อยสกุล
The objective of this project is to design and create the beam with the highest performance, and the performance can calculated by load in newtons by mass in grams. To get the optimum beam, we have to consider about the design factors. First is area moment of inertia. We want the high value of area moment of inertia. It will make the beam can handle high value of load. Second is weight. We want the beam with the lowest weight because it will increase the value of the performance. Third is thickness of groove area. We have to consider about the maximum shear stress occur in the groove area. It cannot exceed the allowable shearing stress of the groove, which is 4.688 megapascal. The last is possibility of making beam. When we get the optimum beam, we will consider that we can cut the metal plates with the exact dimension or not. For the given information, we can notice that brass has yield strength near the aluminum, but the density is more than aluminum for 3 times, so we do not want the brass so much in our beam. Now we will tell you about the reasons of designing beam. First, we set the stainless plates at the outermost layers because they have the highest yield strength. Therefore, they can support load the best. Second, we want the symmetric cross-sectional shape because the neutral axis will lie at the centroid. This makes the same layers can support the equal stress in both tension and compression. Third, from calculation, we can notice that the layer which is closer to the neutral axis give more allowable moment, and some layers can handle the maximum moment of 950 Newton load. So, we set those layers to the lighter weight, which are aluminums. Fourth, for the brass plate, we do not want it because the yield strength of brass plate is nearly aluminum, but the density is more than aluminum for 3 times, so we do not want brass so much in our beam. We set it at the core of the beam and reduce the dimension of it in figure shown. For the result, theoretical specific strength is about 10.99 Newton per gram, and experimental specific strength is 11.11 Newton per gram. For the error percentage, it's just 1.09%. For discussion, the error might be happen from first weight. The weight from our calculation is not the same from the real weight of the measure. The reason is the density and the tolerance from cutting. Second, load. There are 3 reasons for this. First, our gluing process is handwork, so some location on our beam is not strong as we expect. Second, we could not control the proportion of 2 glues, so we change the allowable shearing stress. Third, the beam bent while we was cutting, so it affect the gluing process. Suggestion. First, from our observation, we found out that we need to buff the metal plates before we glue it. This way, beam can carry more load. Second, we designed a cross-section for second testing and found that the specific strength is about 13. But the process of creating beam is too complicated that our beam failed before testing as shown.